So we'll be talking about the modern surveying instrument. It's a part of module 5 from the advanced surveying. So modern instruments are provided with a faster and more precise surveying than the conventional method. In conventional survey, we use chain tape for the linear measurements, while compass and ordinary theodolite are used for the linear measurements. Leveling work is carried out with the help of dummy level and leveling staff. With such surveying work will be slow and tedious, hence the modern surveying instruments are becoming more popular than the traditional surveying. Modern, modern surveying instruments are mainly work with the EDM, that is electronic distance measurement, then works with total station, then they works with the, we have a global positioning system. These all are used in the modern surveying, and these all things are work with the so-called electromagnetic waves. So today in this lecture we'll be discussing about the electromagnetic uh, radiations, the electromagnetic spectrum. So we are surrounded by the electromagnetic radiations. Whenever you watch TV, whenever you hear a radio, when you use your microwave oven, we are surrounded with electromagnetic spectrums. And these electromagnetic radiations or these electromagnetic waves are very essential or helpful in present day surveying techniques, which provides more information. To give example, with a dumpy level you can work up to the distance of probably of 1 kilometer or so, but with the modern instruments like total station, or we have a lidar technology, with that we can cover almost a 5 kilometer area from the station where you have set up your instrument. This electromagnetic radiations or electromagnetic spectrum is divided into almost 7 ranges. In that, the center range is visible range. Then on the right hand side we have ultraviolet radiations. We have X-rays. Then we have a gamma rays. And on the left hand side we have infrared radiations, microwave, or the radio waves. If you compare the wavelength of these ranges, then the wavelength of gamma rays is called the shorter wavelengths, and the radio waves are called as long waves. So if you observe, if you compare with the material, then the gamma rays are of the size of atomic nuclei, which cannot be seen with a normal eyes, while the radio waves are as big as the building size or the human size, you can say that. So in a visible range, whatever colors we can see in with our open eyes, they all fall under the visible range. While the ultraviolet radiations or the ultraviolet waves, UV rays, which are very helpful nowadays in remote sensing technology or night vision cameras. X-rays are not used in the modern instrument. Rather, these X-rays have changed the future or changed the diagnostic of human bodies. Infrared waves, again, we have IR radiations. Again, this is used in night vision cameras. Microwaves, nowadays we use for the microwave ovens, or the heat waves. They are called as the heat waves. In a recent time, the microwave radiations are playing an important role in remote sensing analysis as well. Coming to the visible range. So the visible range, this visible range, wherever whatever we can see with now with our normal eyes, or with the remote sensing sensors which can be detected, called the visible range. That ranges from the point 0.4 to 0.7. Point 0.4 is the violet color, and 0.7 is the red color. And this this is measured in micrometers. So the wherever we see lasers, we have the highest range. This is the darkest color, and with single beam it will come out. And there we use this red color as a single radiation. You can see the range of each 7 colors are mentioned here, like zero point 0.4 to 0.446 micrometer is for the violet. We have a blue which is 0.446 to 0.50. We have a red which is zero point 0.6 to zero point 0.7 micrometers. And you can observe the wavelengths also. As we go on the higher wavelength, the size of the higher color, higher order, we can see the size of the wavelengths as well, while compared to the ultraviolet radiations. And that's why ultraviolet radiations are not play a virtual role in single beam colors, while red plays a virtual role in single beam color as a part of laser. And this laser is very helpful in case of electronic distance measurement. We mainly use laser color. It talks about the hitting point and reverse back capacity, the time taken to hit the object and return back. That is called that technology or that concept is used in case of the laser beams. If you compare, then we have the majorly these three colors called blue, green, and red. These are called as primary colors, and these primary colors are mainly like used in remote sensing part. We'll discuss about it in the next 3 or 4 PPTs. Why we only use these three colors as a primary colors in remote sensing. Whenever we see a white light, that white light itself is a combination of all these is seven colors. And when you pass that natural light with this prism, you can see all these seven colors. Okay. So next part is the ultraviolet radiation. Why the name is ultraviolet? Because next to the violet region, immediate next to the violet region, this ultraviolet region comes, and then the name of this is ultraviolet radiations. This ultraviolet radiations has got a shorter wavelengths, and got the shorter wavelengths, and they are these ultraviolet radiations. Some of the earth materials, some of the rocks, minerals, they emit the fluorescent color when it's been exposed to the UV radiations. This this infrared region is again further divided into two range. That is to be more precise, it is divided as far infrared, mid infrared, and near infrared. But it is again divided into reflected IR and thermal IR. So the reflected IR has the wavelength of zero point 0.7 to zero point 0.3, and this is used in combination with the normal remote sensing waves like RGB colors to get a false color composite. Again, about this we'll discuss in the next topics. While the thermal radiations are quite different than the visible or reflected IR, this is energy which is essential for the radiation that is emitted from the Earth's surface in the form of heat. And this heat can be recorded, and we use the thermal sensor cameras nowadays in order to detect the thermal radiations. So this near infrared lights is close to the wavelength of visible light, and far infrared is close to microwave region of electromagnetic spectrum. So whenever you on a TV, there are some range or the light will pass which cannot be seen with your open eyes. If you want to see this light, you can carry a small experiment. You can take your mobile phone, take a remote, and just on your camera and just start pressing the buttons. You can see uh, color which is been you can see there is some blinks into this light, and these blinks can be easily seen. I'll just perform my experiment, small experiment for you, so that you can understand what exactly means by the infrared region. So I have a remote, and if you use your normal home remotes, when you press this button, any of the button, you can't see any radiation with your normal eye. But if I start pressing this button in a camera, you can see this uh, light blinking. That is because of the infrared radiations which are coming out of the your TV remotes. So these are like thermal energy which cannot be seen properly. So if you take uh, ice cube, that also emits some sort of energy, and that energy which cannot be exactly feel, but the energy is there, that is in the form of infrared. For example, if you can take charcoal burning, it may not give off a light, but emits the infrared radiation which is can be feel in front of with the heat. The warmer the object, the more the infrared radiations will be emitted out of this. You can take this picture as an example. Now this a man is holding a lighter, or the mastic which has been burned. And if you observe, the red color indicates the heat. So in we feel this lighter may not maybe emitting more amount of light or the more amount of energy. But to be frank, when they check body temperature with the infrared, which can be seen in the red in color. So presently we are dealing with the coronavirus, and the coronavirus, the main symptoms of heat. So presently there are possibilities that we can detect the crowded places who is been suffering with the virus with the help of the infrared radiations. So we can deploy our drones in the area. We can deploy the drones in the area, and we can use these thermal sensors to check the body temperature of the human beings. And those who show the high body temperatures, that can be catch hold and sent for the quarantine, or the precautionary measures can be taken out. So you can see these two photographs where the image of the building and a tree shows the chlorophyll in the plant reflected near infrared waves along with the visible light. Even though we can't see the infrared waves, they are always there. The visible waves down drawn with this picture are green, and infrared are plated red. So now you can check this image. So the chlorophyll content, this red, we can see this plantation or this green color in the red form because we combined just this is the RGB picture. This is red, blue and green. When we combine additional color, that is infrared range, we can see this vegetation as red, and the green red can be seen in the form of green. This is again a part of remote sensing which will be discussed. Then comes microwave oven. So regularly we use microwave ovens or the towers which emits this microwave range. Uh, there are only few instruments which use microwave radiation for the distance measurement, but this microwave region is playing a virtual role nowadays in order to manage many of the things. For example, the best way of using this microwave radiations is in the form of uh, the microwave satellite images. So wherever there is a cloud, we always see this cloud can be hide the bottom area, which we have already discussed in the last semester as well. But if you use the microwave region, it can be mug up, or it can be remove the cloud cover, or the remove the smoke cover, and can give the detailed information. So usually in the rainy season, during the flood mapping, during flood management, this microwave region can be very much helpful in order to get the clear picture of the land. This region is between 1 mm to 1 meter, and you can imagine what the size, how big the size is. So here it is given clearly. It can be remove the cloud cover and used in. But this again, the microwave regions are the heat waves which is used for the cooking purpose in the microwave ovens. This is a summary of whatever we discussed. So we have a optical infrared where we have 7 colors. Then we have a near infrared, short wave infrared, mid wave infrared, thermal infrared, and far infrared. In electronic distance measurements, we use short wave infrared waves for the electronic distance measurement. While when we use optical color, we use a red band in case of lasers. And if you want to get a clear picture of the area, we combine this blue, green and red with these three natural colors. Any color can be mapped, and whatever visible things we see, that is because of this three combination. And if we combine these three colors with the near infrared range, we can see a different type of vegetation. But if you see the Google images, we see everywhere the green color. So there it is very difficult to understand which is type of plantation, whether it is shrub, herb, or it is a thick cover, or it is a shallow cover, if the plantation is healthy or not healthy. Understanding that with only true color composite, as red, green and blue, is very difficult. But if you combine with near infrared, you can clearly get a clear picture about the vegetation which can be seen in red color, and give a clear picture about how exactly the plantation is, whether the plantation is healthy, whether the plantation is already dried. All information can be provided. Then comes the microwave range. It has so many bands, as it is starting with 1 mm and goes up to 1 meter range. So this is very high wavelength and can be remove the cloud cover and give the clear picture about the study. Okay, so this is about the today's lecture. We'll wind it up here and we'll start with the total station surveying, then lidar surveying we'll discuss in the next few videos. Thank you.